What's up, guys? Welcome to your last video of science in 5 minutes or less for this week. Today we're talking about polar molecules, and this kind of takes off where we left off last time if you saw the last video before this one. All right, so I'm going to get on with it. Here we go. We left off with the question of, will it dissolve, right? And then the last thing I told you was, the rule of thumb is, like dissolves like. Something that's similar will dissolve something that is similar to it, similar in structure. And that's really important that you read that part of the definition. It has to be similar in structure. Otherwise, it won't dissolve. Okay? Now, what determines whether something is similar in structure? How would you even know that? Okay? It's divided into two categories. One is it's going to be polar, right here, and the other one's going to be non-polar. Now, look at kind of the shape of it, and that'll kind of help you understand whether it's polar or non-polar. Polar stuff typically has, it doesn't look even, like this doesn't look even, versus non-polar, it kind of looks very similar, very symmetrical. And let's get down to a real example. Let me just put myself away. All right, so polar molecules, when one of the molecules is slightly positive and one is slightly negative, that's what we call polar, like a north and a south. It's not, and if you look at this particular molecule, it's not very symmetrical. The shape is weird. Versus this one, the shape is more structured. It's more even throughout. So in your notes, if you've looked at those, there's like a symbol that's a plus and an arrow sign. So let me just kind of define what that is. Okay, so what that is if we're looking, let me scroll down just a little bit. Let's take the case of water. Water has H2O, the two H's and the O. The two H's, we know they're positive, and the oxygen we know is negative based off oxidation numbers. I'm not going to get too into that. But essential, we have, when we look at this, we see that the top part of hydrogen is positive, and then that bottom part where the oxygen is, that's mostly just negative stuff. So we write that as this little arrow symbol, positive at the top, negative at the bottom. So it's definitely polar. It definitely has a positive region and a negative region. And then you say that's polar. Versus the right side, which is non-polar, well, we know that hydrogen is already positive, so we've got all these little positives up here, right? And now we know that carbon has a little E for negative. So as we go from the hydrogen to the carbon, it starts to get negative. They all do. And you could say, yeah, this is also polar, but it's really not, because you've got, why is this doing that? It's got all these bottom ones. And I'll talk about those in just a second, right? It also has these hydrogen at the bottom side facing up. So what happens is it starts to look kind of like this. Positive facing up. Positive, stop doing that, please, thank you. Positive facing up. And then positive facing up. So it starts to cancel itself, right? It's canceling the structure, the positive negativity, and it's kind of non-polar. It doesn't really have a set polarity, not as obvious as this one does. Okay, so why does that matter? Well, in the practice problems, you're going to have to identify whether it's polar or non-polar. So how you can do that is look at the arrows. This polar, it tells you it's polar, but right, if we're just looking at it, the H is positive, and we go towards the negative. There's an obvious positive and there's an obvious negative side. If we look at this one, 3 H's in the end, this whole bottom section of H's is positive, and then the top section is going to be negative. So again, obvious positive negative region. And if we look at the right, it's kind of the same thing. But if we look at these non-polar, we see that now everything's kind of pointing away. And if we look at it, everything's really structured, like everything's divided equally. This one's divided by 3s, this one's divided by 4. So there's no really clear polarity. So we say that that's non-polar, okay? And that's basically what polarity is, like dissolves like. If it's similar,